looks like. Yeah. Can you see something? Hello? Can you see the screen?
Yes, sir.
Sir,
Okay. So what we start today is that it is lecture 9. So it is the extension of what we did the other day. So it is the central tendency and variability, standard deviation and variance. The other day we talked about mean, mode, median. Okay. So again we recapitulate as usual what we do. Okay. So apart from that, we will again go through range, variance, standard deviation, and interpretation of standard deviation, and how the population and sample variance can be defined. Now, this is another second slide. I hope you can see, right? Central tendency and variability, the two most essential features of the distribution. So you can see, right? Hello.
yes, sir.
Okay, you can see my highlighter is moving, right? Okay. So we already talked about that other day about the variability and range. That if we want to get the distribution, then we should have the measure of the location of the center, and then we can get the measure of variability. Okay, and the easiest way to know about the variability is to find the range. So how do you get? So always you search for the lowest value and the highest value, and the difference gives you the range. Okay, that is the easiest way. That's what it has been told, that numerical difference between the largest and the smallest measurement. Okay, so if I say that the height of the students that vary from this to this, okay, so in that case, you will always the smallest height or the and the largest height. So the difference between that between them it gives the range. Now all these things we already did, but again we recapitulate because we have to go through. The mean value is the sum of measurement divided by number of measurements. Then we talked about there are two means. One is sample mean, another is population mean. Because out of the whole population, we take out sample. Okay, maybe out of 100 students, I take only 10 students to study some variable. In that case, whatever is the sample mean, that is denoted by x bar, and the population mean is denoted by mu. Okay, and number of values in the sample is denoted by n, and number of values of the population is denoted by capital N. So these are the, I mean, usual notation. Most of the time it is used. Some books, some other reference, they may have their own way, their own choice, and you can. But only thing for you is the understanding. If you understand what you are going to do, then it would not have any problem. Now, as I said, that by variability, we can get the measure of how the spreading out of the scores, okay, in a distribution. And measure of variability usually accompanies a measure of central tendency, okay, as basic descriptive statistics for a state of score. Now, let's say if I want to take how the variability looks like, first thing I said that one of them is a range. There are four things which gives the better idea. One is range, another is average deviation, another is standard deviation, then variance. in general, we don't talk much about variance. First, we talk about standard deviation. You will see anywhere, okay, wherever there is any sampling or anything, we always talk in terms of either range and the standard deviation. If I say how was the temperature, then we always say okay, the range was this, the standard deviation. Just like okay, if there are a couple of numbers, let's say 12, 14, 14, 16, 16, 18, 20. The smallest and the largest is 20, and okay, one is 12, another is 20. So the range is 8, and we can have the average deviation that we can calculate. There are equations we will show. Okay. Okay. One is median here. Okay. It is average deviation is x bar minus median divided by n. Now, see, there are two data sets here. Okay. For example, we take 3, 5, 7, 10, 10. And another data set is 7, 7, 7, 7, 7. I hope you can see this slide. And what is the mean and median of the above data set? Okay. Now, data set 1, mean is 7. And if you try to find out, you will find that median is also 7. Okay. And if I look into the data set 2, mean is 7. Okay. And median value is also 7. So from this, I'm not very much sure how that distribution is. You know that two data sets are not identical. Because you already know that data set 1 is 357, and here it is 7777. So even if their mean values are same, median values are same. Okay. So they are not
Sir,
identical.
excuse me. Only for me, your voice is breaking for everyone. Your voice is not clear,
Can
sir.
you hear me?
Yes, sir. It is like going low to high, so it's not clear to me. Is it only
Okay.
for me or for everyone? I don't know, sir.
Okay.
For everyone.
Is it like that? Okay, then just wait.
Yes, sir.
I'll be right back. Can you hear me? Hello.
Yes, sir.
Okay. I hope it would be clear right now. Okay. So as I was saying that there are two data sets. Okay. And although they are different, but you can see that their mean and median values are same. Okay. But we know that these data sets are not identical. Okay. The variance shows how they are different. Okay, that's the reason people use variance. Okay, we want to find a way to represent these two data sets numerically. Okay, now uh, one more thing that we talked other day was that if we consider the values, okay, set of values, and whatever the summation of the, I mean algebraic summation of the difference
between the mean value and the actual score, that summation would become 0. So if you look at the average value or the mean value is 5, so the difference between 3 and 5 here, okay, and 8 minus 5, if you keep on having this algebraic sum, ultimately will end up with 0. So that's mathematically has been shown that xi minus x bar. So xi is the any score or any value, okay, of the sample, and x bar is the mean. And if you keep on summing that algebraic summation will always be 0. That is the property of the mean. Okay. And okay, also we talked about that central location median. Okay, that if how to find the median. In case of finding the median, you have to order them. First, it can be they can be in a haphazard manner, maybe 4, then 7, then 3, or again 2. Okay, so you have to order them. Okay, from lowest to highest or highest to lowest, just like that. Okay, after the data are ordered, then if n is odd, then median is n plus 1 by 2th number. Okay, so n is the total number of, okay, um, and numbers. And when n is even, then median is in between two values. One is n by 2 and another is 1 plus n by 2. Okay, you can have this one in any example, just like, and then you can find also. Okay, and this is nothing. This slide we talked about other day, that mean is the balance point of the histogram, or if I draw them data, median is halfway point of the. So it says that 50% of the data falls on one side and 50% of the other data that falls on the other side. Okay, and as I said just in the previous slide, that if the distribution is symmetric about a value, then the value is both the average and the median. And the other day we talked. And if the histogram is skewed, then the mean is pulled away from the median in the direction of the tail. But this is not true for, I mean, uh, if the numbers are not very sequential. Okay, in that case, sometimes it has been found also that this one is not valid. Okay, so there are some special cases. Okay, now. Okay, it is same thing. I earlier we talked that okay, that -3, -2, -1. Yeah, okay, and if the deviation of some values from the mean value are 3, 2, 1, -3, and if we keep on summing, then ultimately we end up with getting 0. Okay, and as we said also other day, uh, so during this recapitulation we said say that it always talks about the two extreme values, either the smallest and the okay, largest value, or smallest and the biggest value. And even if it talks about intermediate values, no information on the how they are distributed, that is not informed properly. Okay. On the other hand, standard deviation or the variance uses all the values and provides information on the dispersion of the intermediate values, because standard deviation is based on how the difference between that particular value and okay, the mean value, and then again it is summation, squared, all these things. And one more thing, as you know, that standard deviation and variance, as because they are square. Okay, so standard deviation cannot be a negative value, or variance cannot be a negative value. It is bound to be a positive value, whereas your mean, median, those values can be negative. Okay, because if you take a couple of negative numbers, okay, -4, -6, -8, and you take the average, you calculate the mean value, you are always ending up with some negative values. So these are basic things, and computation of variance of the standard deviation requires computation of deviation from the mean. Okay, these are all basic knowledge all of you have, maybe, and you can see that there are two. So here you can see one curve is like this, and another curve is this. So this kind of curve, which is having the peak, and okay, say, okay, it is not spreaded so widely, so this is called a narrow. Okay, and while this is a very wide. Okay, although their mean value may be same, but they are okay. As you can see that sigma value, most of the time sigma is used for the standard deviation. Okay, that notation, that are different, that informs how it is spreaded. Okay, so whereas this one you see sigma is 10, here it is sigma is equal to 1.6. So although both of them have the same mean value, but their dispersion of the data are quite different. Maybe some data is falling here, somewhere here, but it's not true for this one, which is having a peak like this. Okay, and okay, now as I said in the earlier case also, that this is narrow distribution. Okay, it is called. Okay, while is the very wide distribution. So if I take the frequency distribution of two data sets, okay, now in how the tails of each distribution changes from being close together to being far apart. Okay, you see the tails here, they are very close. Okay, and that's why they are very, it is called the narrow. Okay, and the peak has become too tall, whereas this one, it is not too tall, while it's very wide. Okay, so that gives the spread of the quantitative data. Now, spread of the distribution refers to how much variability of the data has. And common measures are this variance, standard deviations. Okay, we already talked about this thing. And okay, yeah, as I said, that if it is symmetric curve, okay, then mean, median, both of them fall on the same point. But if it is right skewed, that means tail, it is further this way. That means most of the data fall on the other side. In that case, median, mean is larger than the median. It is not true. Okay, other day I'll again or I'll give you a link in which it shows that it is not necessarily true. Okay, or if your data are not uh, they are sequential. Okay, in that case, this is not true. And in left skewed, that means in other cases where your tail portion is on the left side, it is okay, that most of the data fall on the left side. In that case, mean is less than median value. Now I move to the next, same thing. Other day I showed that data is right skewed, mean will be greater than median. Data is left skewed, mean will be smaller, and symmetric case, mean will be same as median. Okay, so it tells from this kind of uh, I mean distribution, you can tell which one is skewness is how. Okay, how much? Okay, which side the data is falling much. Okay, most of the data is falling on the right side. Here it is most of the data are falling on the left side. So that gives another kind of perspective, but it is not true also for binomial distribution. Okay, but the sorry, bimodal. Okay, if there is bimodal, that means there will be two peak. Okay, and if it is multimodal, okay, that means there are several number of peaks. In that case, it is not true. Just like if you have to find what is the maximum value, if there are a couple of number of peaks, you cannot get it just by differential equation. Okay, most of the time, if somebody ask you how to calculate the maximum value. What you said that, okay, I'll calculate it just by uh, del f by del x, or okay, df by dx, whatever the function is, I will just differentiate, and wherever that is, that point is the maximum point. But if you have many numbers of peak value, in that case, it is not. For that, you have to take help of some other techniques. Okay, just like a genetic algorithm or some other techniques for optimizations. That's a separate area. Okay, now let's talk about some example. Okay, because we have to uh, work out some examples based on which your all examples are, all exams and quiz they are based on. And so here it is a couple of numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9. So many numbers. Okay, 9 numbers, and we want to find mean, median, mode, range. Range, you can easily say that, okay, the smallest is 13, okay, and the largest is 21. Okay, and mean value, okay, fine, you add up and divide by the total number of points is 9. Then you find it is 15. Okay, and uh, here it is 9 is the total number of okay, samples or whatever it is. Okay, so it is an odd number. 9 is an odd number, so median is the middle value. So we have to first we have to order them. Here you can see they are in a haphazard manner: 13, then 18, then again going down, and then going up, again going down, going up, like that. Okay, so rewrite the list in ascending order as given below: 13, 13. Okay, and then there are 9 numbers in the list, so the middle one will be 9 plus 1 by 2, that is 10 by 2, that is 5. Fifth number is the in that case your median would be. Okay. So fifth number would be, and uh, and there are 9 numbers, so the middle one will be fifth number, and median is 14. Okay, um, and the mode is the number that is repeated more than often than any other number. You can see from the list that there are 13. The number is the 13, which has been repeated several times, and largest value in the list is 21. So the smallest and the smallest is 13. So the range is 21 minus 13 is 8. So your calculation from this thing is that mean is 15, median is 14, mode is 13, range is 8. So it is pretty easy for all of you, I suppose. Okay. Now here we have a couple of announcements that I would like to make. Uh, as I said, that we'll proceed with some quizzes. It was today, but okay, well, I could not finish all these things, so it will be on the next day. Okay, there will be quiz. It will be max 10 minutes. Okay, so it will be based up to what it is being taught till today. Okay. Uh, so we cover already this, and then again there is another example. Okay, see, most of the examples and all these things will work out here in the class itself. And if there is anything extra, that link, that website link will be sent. Okay, fine. No other extra note and all this thing will be okay. Most of the notes were given just to have the supplementary of the examples. So from now onwards, we'll cover up here itself in the class, okay, or some links will be sent, so you can go through them to study. Okay, here is another example. If somebody asks you to find median of the following set of points: 15, 14, 10, 8, 12, 8. So that means again here it is a haphazard way. So you have to arrange. Okay, they are let's say in the ascending order, or you can do it in a descending order. That's up to you. So here it is increasing order or the ascending order: 8, 8, 10, 12, 13, 14, 15, 16. Now, how many number? 1, 2, 3, 4, 5, 6, 7, 8. So this is a even number, 8. So it is not 9. Earlier it was number of points was 9. So that was odd number, so it was easy. But here it is even number. So median is the average of the two middle values. So here you have to pick up two values first. Okay. So 1, 2, 3, 4, 5. So fourth number and the fifth number, because if you count from this side, there are three numbers here and another three numbers left here. So these are two. The problem comes when there are large number of, let's say, instead of 8, if I say it is 12, 15 numbers, then you will have to search where are these middle two middle values. Okay. So if you do something mistake somewhere in counting, then you are gone. Okay. So you have to be pretty much, you have to be careful what you are doing. Okay. So here 12 and 13, and then you take the average of them, that gives you the value 12.5, and it is actually the median. Okay. So this is an easy task, but you have to be a little bit careful. Okay. Uh, so be careful what you are doing. Otherwise, we will end up with a mistake. And one mistake, okay, will end up with to have, because I have noticed that some people are trying to copy others, and it is my perception. Maybe I'm not correct, all these things, and they have ended up in MCQ. One person has done mistake, and he is copying others to end up in another couple of mistakes and all these things. Okay. And somebody is copying from some other things and then ending up into kind of errors. So that is not the intelligent way to proceed. Okay. So that you will see in your result also. Okay. So be a little bit careful. Now, other days also I said about outliers. I was plotting one um, this scatter plot. Okay, there also I said some values are that you see, these are outliers. What is an outlier? Outlier is an observation data point that falls well above or below the overall set of data you are dealing with, but there are some kind of disturbance or the noises. Okay, as we say that in whether it is in some signal or somewhere you take the data in electrical signal or somewhere, there are some noises. So that means they are spurious kind of data. They are not useful, but they make some disturbance always. Yeah. But as you are in the process, so you are taking those data. Okay. Mm, and so if you take them, because they may be way off from the actual range or all these things. Okay. And then you are taking, and they are influencing the your whatever is your main target. Maybe you are trying to calculate mean value. The mean value will be influenced by, because if you take something very large value, okay, what will it will try to drag the mean value also. Okay, if there is an outlier which is of a larger value, it will try to drag the mean value to a very high value. Let's say you are trying to take the average value of 7, okay, yeah, 15, 14, 10, 8, 12, 8, 16, 13. Let's say I give you another value 2014. So if you try to take an average, okay, as because of the another outlier 2014, that will become itself, okay, uh, that will make it some values closer to maybe 400 or so, but you know that mean value of this cannot be something like that because of some spurious data like 2014 or something like outlier is dragging. Or if I take some value which is very small, let's say I take one value 0.005, 0.007, okay, and that will drag all these values, mean value or median value, so somewhere very, okay, mean value very to a very small value. So you will end up with something wrong. So be careful about the outlier. So wherever you get any data or wherever you collect some data in sampling, the first job is the screening job. That means you remove the outliers, okay, that so that you do not end up with the spurious value. It is just like screening off, and then you are, okay, then you do some processing. Okay, fine, this is my outliers are gone, so let me see how is the distribution. Then you start processing with calculating mean, median, mode, or do some other operations. Okay, the median is said to be resistant to outliers because you are taking only the okay, the middle values. Okay, so if you are adding something or removing that thing, it doesn't, but mean value that gets affected. So I move to the next slide. So here it is. Always there are some kind of confusion that comes up. Okay, now just like this kind of in a histogram or something, okay, um, you look and you become very confused which one is bigger, mean or median. So you have to be very precious and you have to be looking on what you are doing. Okay, so actual distribution you have to look and calculate, and then only you will become very sure and certain. This is an example. Okay, now we come to the, so far we had been discussing about this standard deviation. Okay, standard deviation. Now, what is the formal definition? Formal definition is standard deviation measure the standard distance between a score and the mean. Okay, and it is defined as the deviation of the values or data from an average mean. Now, if the value of the standard deviation is smaller, that means, okay, the values are very close to the average value. That means mean value is close to those values. That means they are not very dispersed, they are not very wide, they are not scattered, you can say. Most of them are maybe 12, another is 13 or so, another is 12.5, another is 13.1 or something like that. But whereas if your higher value of standard deviation, that gives an indications that all these values are very wide. Maybe I am taking one value as 12, another value maybe 20, another value maybe 30, another value maybe, okay, 5.5, or another maybe 45. So the average value, this okay, from the average value, they are very scattered away. Okay, and as I told you, as because this is a value of square, okay, the derivation that will show, I mean that value, okay, that formula of standard deviation, okay, so it is a square, so it cannot be negative. Okay, sometimes called the root mean square deviation from the mean. This name says how to compute it from the inside out. That also gives some idea. Now, again, I move to the next slide again, okay? Another slide. So here is the steps. I hope you have all gone through this one. How to do it, okay? How to calculate standard deviation. Okay, here you calculate, okay, uh, calculate the deviation. So what you do is that basically you have to have a table. Best thing is that if there is less number of data, then you can have a table. or the way I prefer to do is that I put them in an Excel sheet, all data. Okay, then I make the deviation or the difference between the mean and that actual score. Okay, then I put them in another column, then another column in which I make them square each deviation. Okay, then compute the mean of the square deviation. So and then take the square root. That means what I do in Excel sheet, I take the difference, then I square the difference. Okay, then I add them up and then divide them by the number of the samples and numbers, okay, of the data. That gives me the mean of the square deviation. Then I take the square root. As because this is a square deviation, so it can never be negative. Okay. Now, finally, okay, you may argue that square root is plus minus, okay, but in general, we take it plus. Okay, so, okay, finally, because it's the actual, if you look into how this is, okay, when in your linear regression or some regression, okay, you are actually looking into the difference between that middle line, that data from that line. Okay, so distance cannot be just a negative value. So that's why it is okay. That deviation is standard deviation is positive, and finally take the square root of the variance to obtain the standard deviation. As you know that okay, as we will be also looking that the square value, okay, that is called the variance. So the square root of variance is standard deviation. Now also we look into the um, uh, general formula by which they are calculated. Now, one is variance, that is sigma square, okay, is equal to the average square deviation from the mean value, okay, and sigma value is called the standard deviation. Okay, now in general, people calculate two types of standard deviation. One is population standard deviation and another is sample standard deviation. Okay. Now sample means, that means, okay, maybe you have taken 10 samples out of uh, mm, out of this 100 students, okay, uh, or population. Uh, okay. So in that case, okay, it is calculated like this: x minus x bar divided by whole square divided by n minus 1, whereas for population is x minus mu. Okay, mu is the population mean, whole square divided by n. So you have to remember this equation, okay, and you have to know where you are going to apply which one. Okay. Just wait. Huh? Okay. So it is in a just in the form of a chart. It has been shown. It's nothing great or something. Okay. It has shown just like your logical chart or logical okay loop. It has been shown that add the deviations and compute the average. Find the deviation. That means distance from the mean. Square each deviation. Then find the average of the square deviation. That is called variance. Take the square root of the variance, and that gives you the standard deviation. So variance and standard deviation, they are very much interrelated. One is square of the another. So okay, square root of variance is okay, this is sigma square, whereas people refer it in terms of sigma. Okay, so you will see if you are in industry, most of this time you might have already done some or attended, or you might have already experienced somewhere Six Sigma. Okay, so I hope you know about Six Sigma, that if there is some amount of rejection, You always try to measure it, whether it is falling within 6 sigma or not. Okay, so your quality in TQM, total quality management, 6 sigma is one of the criteria that one has to follow. Uh, if you do not do that, that means okay, um, you are not very sure certain about the um, uh, about how the rejection is. Okay. Now again, one example, it's nothing great. Here it is, you can see n is equal to 5 at, okay, 5 numbers, 5, 10, 15, 20, 25, okay, and the x bar, that is their average has been done like 15, okay, and this is the difference, x minus x bar. So as I said that for small numbers of samples, just like here it is 5, so you can make a table like this, x minus x bar, then in x minus x bar whole square, and then you add them up, total is here 250, and then you divide by total number, that is 5, and you end up with 50. That is the variance. And what is standard deviation? That is square root. So one is sigma square, and this is sigma. So there is nothing great in it. Anybody can do it. Okay, so the problem comes when there is a large number of data. Now, again, we show another example. Now, it is let's say this is a walking time from the hostel or the apartment to one professor's course on operator algebra. Okay, and let's say we have 9 students, and their name are shown like this thing: TS, PC, AA, CS, NG, SQ, EW, TB, GW, and the time is, let's say it is 39 minutes, and for some person it is 21, another is 9:32. So it is pretty way off. It's not exactly close to the okay. So whoever is the closest is this person, maybe within the campus. Okay, and other fellows are away off. Okay, so what is the population mean and the standard deviation? And population mean in this case is that the 9 students, and choose a sample of 4. Out of them, you choose 4 and compute the mean and standard deviation of the sample. So that's another task. So here you have this thing, as you can see, sigma value. Okay, okay. One is how it is calculated. So mu value. Okay, this is the mean value. Okay, it has just has been uh, calculated just by adding them up, and there are 9 students, just averaging shows like this thing, that 26.44, and sigma standard deviation is that uh, each individual value minus the mean value, that whole square, and then square root, that makes this much. And suppose if you take these samples out of these 9 numbers, 21, 30, 45, 12, and then you take the average, then it is x bar, then you come up like this thing, and this is this sample standard deviation. That's why it is, as I told, n minus 1. Okay, so here it is n, but here it is n minus 1. So n is here the number of the samples. So you have to be very careful, see the difference between them. Okay, and then square root, and then you come up. Now it is your choice. That's what you have picked up. That's why you have picked up. Now, instead of these 4 values, if you pick up some other values, okay, let's say I pick up 39, 9, 30, and let's say another 11. And if I do the calculation, maybe I'll be ending up with some other, uh, I'll be ending up with other sample average and the sample standard deviation that would be different. Okay, because for them, they are not going to be the same values, okay, because the average in that case will be different and their spread is also different, okay. So that is another example. Now uh, it is another example in which it has been asked six students that how much they study, how many hours, okay, per day, and the answer is like somebody says 2 hours, 6 hours, or some other fellow said 5, 3, 2, 3, and you are asked to evaluate this standard deviation. So suppose you get them this in the form of a table and you are very curious, okay. um, I hope you can follow this thing, right? Hello, are you there?
Yes, sir.
Yes, sir.
Okay, I can hear only two, three, four people's voice. Where is Mobin Akhtar? Mobin,
Sir.
you are there.
Yes, sir. I'm here. Yes, sir.
And Nand Kisa, Nand Singh. Hello, Nand. Avinash Kumar. Okay, I don't hear from them. Nand
Yes, sir. Yes.
Singh, you are
Avinash
there.
Kumar.
Avinash Kumar is there. Okay.
Yes, sir.
Okay. And Nand Singh and Nand Kishore. Okay. So find the mean of the data. You find this value and then construct the table. Okay, you can have a table like that, and then you can see how the difference is, and then square, and then you make a table, and then so here in short, it has been shown instead of the total table, it is shown, and it is shown 1.643. So I would always suggest all of you just to go like this kind of table. Okay, if it is asked, please go through. Just it may look a little bit cumbersome, or maybe sometimes it is tedious. Sometimes you may not like it, but here the chances of the error is less. Okay, otherwise you may end up if you try to do visually, maybe in this kind of thing you may end up some kind of mistake. Okay, so I would always suggest that you make a table, then you do the square, then first you make the difference, then another column square of that, then mean value, and then square root. So that what it has been shown in okay, I told you that's what. Okay, that 2653, and the difference has been shown here. Then again this is squared, and then it is averaged. So that's the way. Okay, n minus 1, as because it is a sample standard deviation, that's why you see the equation here. Okay, the denominator is that n minus 1. Okay. So another example of sample standard deviation of data collection is okay, that it shows that there are a couple of data 4, 6, 10, 14, 16. Okay, now total number of data is 5, and if somebody asks you how is the variance, then you have to calculate. Okay, this is another formula. Okay, that comes up. We'll talk about this also. That sigma x square by sigma x square by n divided by n minus 1. Now, so you just actually come up from here 26 and 5, and standard deviation is square root of sample variance. So that becomes 5.1. Now, as I said, so the variance is nothing, but it is the square of the standard deviation. So population variance is just sigma square. It is not the sigma value, and it is x minus mu, whereas mu is the population mean. Okay, and if you take the square root of this one, Okay, that would become the populace standard deviation. So just only the terms wise they are different. One is population variance and another is population standard deviation, and mu is the population mean. Okay, and variance is equal to the average square deviation from the mean. So it is nothing great. You have to just uh, take e square, subtract mean, square the result, find the average over the square. That's the variance. Okay, the same equation here, it has been repeated. Now, again, the same thing, population variance, sigma square for the population variance, mu is the population mean, n is the total number of values, okay, sigma, summation. One thing you have to be very careful, okay, about their unit. Variance unit is always length square, okay, or something like that. Maybe here it is inch square, okay. But standard unit is just the length or whatever that value is, okay. The original data value. Maybe if I calculate with the weight kg, maybe that will be variance will be kg square, okay, and the standard deviation will be only the kg. So one is just the original data, and the variance okay, unit will be the data square, okay. So standard deviation may sometimes be preferred over variance. So that's why I told you that people prefer to talk about standard deviation. Anywhere, any data, you will say that the mean value is something like this thing and standard deviation is this. Anywhere you will see this value. Okay. And as I said, that variance and the standard deviation, they will be always some positive value because it is already a squared value. Okay. So you cannot expect it to be a negative value. If you see something somewhere it is negative, that means something is wrong, okay, from your end. So it's the same value we already talked about. Okay. Here it is shown how the distribution is, how the mean value, median value, okay, and mode value. Okay. So it totally depends how your distributions are. Okay. That's the way it is. And standard deviation 6.47. Okay. Okay, another term is coefficient of variation. Okay, coefficient of variation. See, all these terms are basically they are for the sake of convenience. Some people find okay in some cases maybe if I talk about variance, maybe I look better instead of sigma. Sigma square is looking better. That's why they use it. Okay. Otherwise, standard deviation itself serves most of the purpose. Okay. Standard deviation of data divided by its mean gives the coefficient of variation. So a sigma is okay. Uh, uh, that standard deviation, okay, and if you divide by the mean, you get okay, you get coefficient of variation and expressed in percent. So if you multiply it by 100, then you get how much percentage. Okay, and as because you can see that it is the sigma divided by x. As I said, that the standard deviation will have the unit of the length or whatever that original data, and this is the data mean. Okay, so this ratio is always a dimensionless. So coefficient of variation, okay, that ends up being a dimensionless data. So that's what it has been told here, that all these this coefficient of variation is dimensionless, whereas others are dimensional. Okay, either standard deviation or your variance. Hence, the coefficient of variation is very useful quantity for comparing the variability in data sets having different standard deviation and different means. See, so as I said that it is only the matter of convenience, how you are, okay, how what you want, okay. So if you see that you can represent them easily, something you always try to look for that. Okay. Now interpretation of standard deviation. Okay. sometimes you physically difficult to interpret, but you know that okay, one meaning is that if the value is larger, as I already told, that means a larger variability. That means its mean value is deviating too far from each score or each particular sample value. Okay. And standard deviation is widely used to approximate the proportion of measurement that fall into various intervals of values. Okay, it happens for data if the data has well-shaped distribution. Okay, basically it tries to cover everything, all sorts of data. Okay, maybe your various intervals. It tries to encompass. It's just like in one umbrella. It tries to cover. Okay, maybe it's a data spreading. So you try to say, okay, if I say this standard deviation is this, so people would have the idea that how much this maximum value or the minimum value they can vary. Okay, so the little bit about also the range how it can vary. The larger the spread in the data, the larger the standard deviation. We told, okay, standard deviation is zero only and if only if the set from which it is computed has all of the elements the same in which the mean of the set is this number. Okay, so first you have to have the mean value same. That means most all of them have the same value. Then only you can have x bar, xi minus x bar will be zero. Otherwise, there is no other way. Anything that you square of that, whatever, even if it is a negative value, if you square, it will become a positive. Okay, so only it can become zero if xi minus x bar is zero. Okay, and that has to be true for each value. Okay, because you will have the summation of them, then you will get the again mean them, then square root. That can give standard deviation. So all of them have to have, they have the same number and they have to be same as the mean value. Then only it is feasible. Otherwise, no way it can be zero. And standard deviation is influenced by outliers because the mean value, okay, it's get influenced by the outlier. So your x bar value is getting changed. Okay, because of this, maybe it will become very high or very low. So your xi minus x bar, that would be influenced. So your standard deviation value will be either drag too high or maybe drag too low. So that you have to be very careful. And that's the reason that it is asked that first of all you try to remove, okay, this outlier from your data, which are spurious, which are not useful for them, for your purpose. Okay, the deviation from the mean of the set to the outlier is a large number in absolute value. Okay, and then the standard deviation yields more information than the range of this set. Why? You just think about this thing, then you will end up, because if I say the range, okay, you know the lowest value and the highest value, but how other values are, if you want to have a look, then only standard deviation gives that, okay, how these values are deviating from the mean value. Then you can have the idea, okay, how the intermediate values are. Okay, then only you will be getting that perspective from your standard deviation. Now, I think I'll come up with these values, okay, 68%, 95%, when I'll be talking about this binomial. Okay, I don't want to go into details. And there are a couple of properties there, that if a constant is added to every score in a distribution, standard deviation will not be changed. That is one of the property, okay, for standard deviation. Okay, and similarly, uh, if you visualize the scores in a frequency distribution histogram, then adding a constant will move each score so that the entire distribution is shifted to a new equation. So Okay, if you plot them, you will see that this plot is moving also to the right, okay, or maybe to the left. It's just a matter of what constant you are adding. Okay, the center of the distribution, the mean changes, but the standard deviation remains same. As I said, that if you maybe your distribution will move to the right, okay, so the mean value will get changed, but the standard deviation, because all corresponding values are getting changed, mean value is changing, the scores are getting changed, and if each score is multiplied by a constant, the standard deviation will be multiplied by the same constant, and multiplying by a constant will multiply the distance between the scores, and because the standard deviation is a measure of distance, it will also be multiplied. So it's a simple these are simple rules. If you add up, that means it will be shifted up, and if you multiply, that means okay, everything will be multiplied here also. So it's a if you okay, provided you multiply by a constant, okay, all these thing here it is a constant, you should be very careful. uh, these are nothing but just it said what are the okay, in one case the equation is n, another is n minus 1 in sample. As I said, here it is n minus 1. Okay, so these two are uh, because just to avoid some bias. Okay, otherwise the sample will consistently underestimate the standard deviation. That's the reason it is used. This okay, I don't want to go further. This thing we will be talking about later, that Six Sigma and all this. Okay, um, so we end up here, and in general, we have already covered most of the part of the standard deviation, variance. Okay, and as I said, that the sample variance is same thing. You have to be divide by n minus 1. Okay, uh, and it is also to informed why this is n minus 1. Okay, an unbiased estimate of the population variance may be observed by defining the sample variance. Okay, so here we end up close here. Okay, uh, and that's all we want to cover until today. Okay, uh, and next class will be trying to finish the rest of the portion of the standard deviation, if any is anything is left over, and but most of the cases you have to be very careful what equation and what are the uh, okay, how you are taking um, the data. Okay,
Okay.
that it looks sometimes it is boring, but more okay, once you work out, then it becomes easier way. And I'll ask Vijit to distribute this one, okay, later on. Okay, maybe tomorrow. Okay, so that day after tomorrow you can look into the quiz.
So this is the only topic we'll be covering on the quiz, sir.
Right. So it will be covering other day, last day, that was mean, mode, median, and today's standard deviation and variance. Okay. These are the things that it will be covered.
Okay, sir. Thank you.
Right. Okay. So if you have any questions, just let me know. Okay. Otherwise, we end up, we have already gone further than more than time. Okay. Okay, then, bye.